In 11.3, we are going to talk about the different shapes of different distributions that you might see. So, in the previous sections, you looked at different ways to display data. Let's just say we have a bar graph, or in this section, we are going to learn about histograms. Histograms are the same thing as bar graphs, except both of our variables, we are dealing with numbers. They are quantitative. So we're dealing with numbers. Anyways, we'll get to that later. As you can see here with our bar graphs, we kind of have three different types. I'm going to start with the one in the very middle. So for this middle one, we see that our highest peak is at the very center, and then going off on both sides, they kind of match up. So what we would call that is just symmetrical. Or symmetric. All right, with this one here, our peak is not in the middle, and we can see that we kind of have a tail going off to the left. So since it's longer on the left-hand side, our tail is going off to the left. What we would call this distribution is skewed left because our tail is going off to the left. And then that would be just the opposite for this one over here. Our tail is on the right, so this is called skewed right. Okay, so we are going to do an example where we actually make a histogram now. All right, so we have a frequency table over here. It shows the number of raffle tickets sold by students. So we are given this information. We are going to create a histogram using that information. Okay, one thing about a histogram is your frequency should always be along your y-axis. So I labeled it going up to 30 because my highest point is 25 and I just want to be a little bit above that. And then our number of tickets will be our x-axis. So what I'm going to do is I am going to label off different groups using my number of tickets, the categories that they gave here. So I'm going to turn it sideways. First one is 1 to 8, then 9 to 16, 17 to 24, and then you just keep going from there. Okay, so since I have these all labeled here, I'm just going to go through, look at the actual frequency. So from 1 to 8, the frequency is 5. I am not going to push my bar all the way up against the y-axis because 1 to 8 does not include 0. So this should look something like this. My 5 is halfway between 10 and 0. So my first bar should look like that. The next group goes all the way up to 9, which is about right here. I want them to connect now because we had 1 to 8, then we're starting right at 9. So about right there. The next one goes up to 16. This would be 15, so I need to be a little bit above that. Then to 25. This is not perfect. I don't expect yours to be either. Then we're down at 20. And then 8 and 7. All right, so if we were to kind of analyze this distribution, looking at the three options we have up here, obviously data in real life is not going to be perfect. You're not necessarily always going to see a perfect symmetrical graph. So what you want to do is look for any tails that you might have. If I were to just draw a little curve above this, I would see that I really don't have any tails at all. So the closest one that this would fit into is, I would say it's symmetric. So we could say the distribution is symmetric. All right, something about a symmetric distribution. When you have a symmetric distribution, that means at the very center, that is where your mean is going to be. So that's where your average, your mean will be. Then we can use something called the standard deviation for the variation. Okay. Another example. We're going to go through the same thing, but this time we're going to create our own frequency table. So we have the speeds of 30 motorists. They are all listed right here. Part A says create a frequency table with 6 intervals starting with 31 to 35 and then draw a histogram. So I'm making my frequency table 31 to 35. We have 6 intervals. We want them to be the exact same size as this here. Since this goes from 31 to 35, that means for the next one I need to start at 36. And because we went up 4, we added 4 to get from 31 to 35. I'm going to add 4 to here. So we should be at 40. Okay, there's number 2. Next one should start at 41. Add 4. We're at 45. There's 3. Next one should start at 46. Add 4. We're at 50. Next one should be 51. Add 4. We're at 55. And then we need one more. Start at 56. Add 4. We should be at 60. Okay, what I want to do now is I'm going to go through and I'm going to count how many of these speeds lie within this range. So from 31 to 35, that's what I'm going to count over here. So there's 1, and there's not very many. All right, so for that one, I only ended up with 1. I would do the same thing going through all of this. So I would go through my list, count up all the ones that lie between 36 and 40. For that, I should get 3. 41 to 45, we should have 5. 46 to 50, we should have 6. Then 11, and then 4. So you would just go through, count how many are within each of those ranges. All right, now we are going to draw our histogram down here. Again, frequency is on your y-axis. That means speed is going to be on our x-axis. I'm going to look at my frequency. I see that my highest number is 11. I am going to label by 4s, and I'm going to go up to 12. So 4, 8, 12. Then I need to label my ranges on my speed. All right. Okay, then you just create your histogram. So 31 to 35, we're only at 1. So this will just be a nice little short bar. The next one is 3, so we're almost up to 4, but not quite. Then 5, a little bit above 4. Then 6. Then we're all the way up at 11. And then back down to 4. Okay, so here, if you were to look at the example in your book, it says that the speed limit is actually 45 miles per hour. So let's kind of interpret this graph here. Again, I'm going to draw a little curve above it to show it. You don't have to do this part. I like to because I can see it better that way. So to me, it looks like we're tailing off to the left. So I would say that this graph, let me move down. I would say it's skewed left. Okay, with a skewed graph, in order to see your distribution, you want to use a 5-number summary. which you guys learned about already. And with that, you're going to create a box and whisker. So, if we see here, because our speed limit was 45, I have high numbers up here. So from that, I would probably say that most were speeding, which you could also see if you created a box and whisker plot.